Welcome to the DIY Honda Garage channel. The DTC P0300 indicates a random misfire occurring within the engine of the 2006 to 2011 Honda Civic models. A misfire happens when the fuel-air mixture in the engine cylinders is not igniting properly. This can lead to decreased engine performance, increased emissions, and potential damage to other components, particularly the catalytic converter. It is critical to understand that if this DTC persists, it can activate the malfunction indicator lamp, MIL, warning the driver of potential serious engine issues. Additionally, P0300 can be accompanied by specific cylinder misfire codes ranging from P0301 to P0304, which correspond to misfires in cylinders 1 through 4 respectively. Understanding and diagnosing this code promptly can help prevent further complications in the vehicle's engine system. DTC P0300 signifies a random misfire occurring across multiple cylinders, suggesting that the engine is not operating efficiently. A misfire is when one or more cylinders fail to ignite the air-fuel mixture properly, leading to power loss and increased emissions. The affected components primarily include the spark plugs, ignition coils, and the fuel delivery system. The engine cylinders are located in the engine block and are responsible for housing the combustion process. A failure in any of these components can cause the malfunction indicator lamp to illuminate and lead to the storing of additional codes related to individual cylinders, such as P0301 for the first cylinder, P0302 for the second, and so on. Effectively diagnosing this DTC can reveal various underlying issues that need immediate attention to ensure engine health and performance. Several factors can trigger DTC P0300. Worn spark plugs are often the first suspects, as they fail to provide an adequate spark for combustion. Faulty ignition coils can also contribute to misfires by not delivering enough voltage to the spark plugs. Another significant cause may involve fuel delivery issues, such as low fuel pressure or a clogged fuel injector, which can impede the amount of fuel needed for proper combustion. Sensor malfunctions, including issues with the mass airflow MAF sensor or the manifold absolute pressure MAP sensor, can lead to incorrect air-fuel ratios, exacerbating the misfire condition. Lastly, mechanical problems within the engine itself, such as low compression or vacuum leaks, can contribute to random misfires. Identifying and addressing these potential causes is crucial for effective repair. The symptoms associated with DTC P0300 can significantly impact the driving experience. One of the immediate signs is that the engine may run roughly, causing vibrations and instability. Additionally, drivers may notice decreased fuel efficiency as the engine struggles to maintain performance. Increased emissions are another concerning symptom, as frequent misfires can lead to harmful exhaust gases entering the atmosphere, potentially triggering strict emissions adherence penalties. The malfunction indicator lamp, MIL, is likely to illuminate, informing the driver of an issue requiring attention. It's essential to observe these symptoms closely, as failing to address them can lead to further engine degradation and more costly repairs down the line. The initial step in troubleshooting DTC P0300 involves turning the ignition switch to the on-to position. This powers the vehicle's electronic systems without starting the engine. Next, it's essential to clear the DTC using the Honda Diagnostics System, HDS, which refreshes the vehicle's diagnostic data and prepares it for new tests. After clearing any existing codes, Start the engine and allow it to idle without loading for a few moments. This step is crucial as it enables a stable environment for testing and observing any immediate issues that may arise. Monitoring the onboard diagnostics at this stage is essential to observe whether the code emerges again, which will guide further diagnosis. Keeping a close eye on the system status will help in identifying any underlying issues promptly. After allowing the engine to idle, the next step in troubleshooting DTC P0300 is monitoring the OBD onboard diagnostics status for DTC codes P0301 through P0304. This is done using the HDS, which provides real-time data and a comprehensive view of the engine's performance metrics. It's vital to check if the screen indicates failed after observing the data for a few minutes. If it shows failed, this indicates that there is an active issue requiring detailed examination of the individual cylinder misfires. If the screen indicates passed, it suggests the engine is currently performing well, and further checks are warranted based on the condition. In cases where it shows executing, continue idling until the system can provide a conclusive result. If the status reads out of condition, it may be necessary to wait a few moments before checking again, indicating the engine needs time for the system to refresh. In this third troubleshooting step for DTC P0300, the focus shifts to checking misfire counts for each cylinder, specifically from CYL1 to CYL4 using the HDS. This provides detailed information regarding which specific cylinders may be experiencing misfiring issues. Monitoring these counts for approximately 10 minutes is essential to gather consistent readings that represent the engine's performance under idle conditions. Should any of the cylinders show elevated misfire counts, it indicates a significant problem that needs to be investigated further. This data is crucial as it pinpoints the cylinder that requires attention, leading to a more targeted approach in the subsequent steps of the troubleshooting process. If no misfires are indicated during this period, proceed to the next step, focusing on evaluating other driving parameters. The fourth step involves taking the vehicle for a test drive to assess engine performance under various conditions. During this step, it is vital to focus on specific recorded freeze data parameters, which include engine speed, VSS, vehicle speed sensor, REL-TP sensor, relative throttle position sensor, CLV, calculated load value, and APP sensor, accelerator pedal position sensor. Observing these parameters during the test drive can provide valuable insight into how the vehicle operates in real-world scenarios and may uncover conditions contributing to the misfire. If any parameters appear to be outside typical ranges, these could point to additional concerns that need addressing. Careful observation can reveal whether misfiring occurs only at particular speeds or throttle openings, aiding in diagnosing the root cause effectively. This step is essential for correlating diagnostic data with actual vehicle performance. The final repair verification step is essential to ensure that all repairs related to DTC P0300 have been properly completed. This involves thoroughly checking the vehicle's systems to confirm that any identified issues have been resolved, such as replacing worn spark plugs or faulty ignition coils. After repairs, it's crucial to clear any remaining DTC codes in the HDS, refreshing the vehicle's diagnostic information. Following this, a test drive should be conducted to confirm that the vehicle operates smoothly without reactivating the misfire codes. Monitoring the OBD status during this phase will also indicate if any new codes appear, ensuring the solution is comprehensive. A successful resolution means that the engine runs efficiently with improved performance and decreased emissions, effectively clearing any persistent issues. Preventive maintenance plays a critical role in mitigating issues such as those highlighted by DTC P0300. Regularly checking and replacing spark plugs can prevent misfires and improve ignition efficiency. Routine inspections of ignition coils are equally vital, as faulty coils are a common cause of misfiring conditions. Monitoring the fuel system's performance, including fuel pressure and injector functionality, ensures that the engine receives the correct air-fuel mixture for optimal combustion. Conducting these maintenance tasks at regular intervals will not only prolong the engine's lifespan, but also improve fuel economy and overall performance. Additionally, regularly servicing the vehicle according to the manufacturer's recommendations can help catch issues early, avoiding costly repairs in the long term. In conclusion, DTC P0300 represents an important diagnostic code indicating random misfires that can significantly affect engine performance. Understanding the potential causes, such as worn spark plugs, faulty ignition coils, and fuel delivery issues, is crucial to take effective corrective actions. The troubleshooting process is structured to identify and resolve the underlying issues accurately, from initial diagnostics using HDS to final verification of repairs. Moreover, implementing preventive maintenance strategies can greatly reduce the likelihood of facing similar problems in the future. Early detection and resolution of misfire codes will help maintain vehicle health, improve fuel efficiency, and ensure compliance with emissions standards. Please like and subscribe to the channel. See you next time.